In Unit 10, we're going to talk about ratios, rates, and proportions. And in Unit 10, Section 1, we're talking about ratios and rates. So the first thing we need to do is define what a ratio is. So a ratio uses division to compare two quantities. So if we're going to have the two quantities 6 and 8, we could write those as a ratio three different ways. We could write it as a fraction, 6 over 8. We could write it with a colon, and that's read 6 to 8. Or we could write it with the actual word 2 and have 6 to 8 that way. But again, we're just taking two quantities and using division to compare them. So if you look right here, there's a definition out of the book. Again, you can write two quantities in three ways. I already talked about that. But there's an example, another example of how you can write them three different ways. Then you have an example that says Sam shot 50 free throws. He made 35 of the free throws. Write the ratio of makes to misses in simplest form, then write the ratio in three ways. So I want the ratio of makes to misses. It said he made 35 and he shot 50 total, which means he missed 15. So the first thing they want us to do is write this in simplest form. Both of these can be divided by 5, and that'll give me 7 over 3, which would be simplest form. So that's one way I could write it. Another way I could write it is with a colon, and I could also write it with the word 2. So that's simplest form and then written three different ways. On the next part, it says comparing and ordering ratios. So we need to go ahead and define what equivalent ratios. So equivalent ratios are when two ratios have the same value. So one example is if you have the ratio of 4 to 2, an equivalent ratio would be 2 to 1. Let's have the same value. So at the bottom of the page, it says we're going to order the ratios from least to greatest. From our definition of ratios, we know that ratios use division to compare quantities. So the first thing we need to do in order to put these in order from least to greatest is to put them all in the same form. So we're going to go ahead and divide all of them so we can turn them all into decimals. So when I do 6 divided by 3, I get 2. When I do 13 divided by 4, I get 3.25. When I do 19 divided by 2, I get 9.5. When I do 15 divided by 10, I get 1.5. When I do 8 divided by 2, I get 4. So now I want to put these in order from least to greatest. So my smallest decimal is 1.5. I need to write that in its original form though. So its original form was 15 to 10. So 1.5 is gone. The next one is going to be 2, and its original form was 6 to 3. So 2 is gone. Next up, I have 3.25, which original form was 13 to 4. Next up, I have 4, which original form was 8 to 2. And then I have 9.5, and its original form was 19 over 2. So I've written those in order from least to greatest. All right, I'm going to leave number 2 for you guys to go ahead and try. On the back of the first page, we are looking at finding a unit rate. So before we can find a unit rate, we need to define what a rate is and what a unit rate is. So a rate is a ratio of two quantities measured in different units. So a ratio was using division to compare two quantities. For it to be a rate, you need to have two different units. And then the unit rate is a rate with a denominator of 1. So if you look at the directions, it says find the unit rate. Our sample rate is 24 people over 6 cars. So again, there's two different units, people and cars, which makes it a rate. And then to make it a unit rate, we need a denominator of 1. So to make the denominator 1, we have to divide by 6. But if we're going to do that on the bottom, we also have to do that on the top. So if we divide 24 by 6, we're going to get 4 people. And then 6 divided by 6 gives us 1 car. For the second one, our denominator is 4. So if we do 4 divided by 4 in order to get 1 pound, which is what we want, we also have to do 5 divided by 4, which is going to give us $1.25. So to find the unit rate, just take the denominator, divide it by itself. So divide the top and the bottom by the denominator. In the next section, it says writing an equivalent rate. So we've done a little bit of this before, but we're going to have to use a conversion factor to come up with the equivalent rate. So for the first one, we have 12 kilometers over 1 hour, and we want to find out how many meters that is in 1 hour. So we're going to start by writing our original, so 12 kilometers over 1 hour. We're going to multiply. We're trying to turn kilometers into meters, so kilometers needs to be on the bottom now, so it cancels out. Meters needs to be on the top. And there's 1,000 meters in 1 kilometer. So I can go ahead and cancel out kilometers because it's on the numerator of 1 and the denominator of the next one. So now I have meters over hours, which is what I'm looking for. So 12 times 1,000 is going to be 12,000 meters over 1 hour. So that's my equivalent rate. For the next one, it says 20 cars over 1 minute, and we want to turn that into cars over 1 hour. So I'm going to start by rewriting. Sorry about that. I'm going to rewrite the first one, 20 cars over 1 minute. I want to turn minutes into hours. So I need to put minutes in the numerator because it was in the denominator of the first one. So that means hours will go in the denominator. There is 60 minutes in 1 hour. So minutes is going to cancel because one's in the denominator, one's in the numerator. So I have cars on top and hours on the bottom, which is what I want. 20 times 60 is going to be 1,200 cars per 1 hour. All right, number 3, I'm going to let you guys go ahead and try that. If you're at home, just go ahead and look up the conversion from centimeters to inches. If you're at school, you can use the back of the textbook for that conversion rate. Number 4 on the back side is a little bit more confusing because you actually have 2 conversions you have to do. So we have 525 feet over 1 minute. We want to turn that into meters over seconds. If you look, it's not actually an equal sign, that's a congruent sign, or it means about, because we're not going to be able to get an exact number. So I'm going to start by rewriting the first one. So 525 feet over 1 minute. And I'm going to start by working on the minutes. I want to turn the minutes into seconds. So since minute is in the denominator, it needs to go to the numerator, which means seconds will be on the denominator. I know that 1 minute is 60 seconds. So now minutes can cancel out. So right now I have feet over seconds. Seconds is what I want in the denominator, but I do not want feet in the numerator. So I'm going to have to convert feet into meters. Since feet are in the numerator, they have to go in the denominator so they can cancel out, and then meters goes on the top. I know just from looking at the back of the textbook that 1 foot is the same as 0.3048 meters. Okay. Feet in the numerator, feet in the denominator, those can cancel out. And now I can go ahead and multiply. When I multiply across the top, I get around 160.02 meters. And then when I multiply the bottom, I have 60 seconds. Now I want how many meters in 1 second, so I can go ahead and divide top and bottom by 60. I'll get 1 second on the bottom. On the top, I'll get 2.67 meters. And then that'll be my final answer. And again, that's not exact. That's around 2.67 meters in 1 second. All right, moving out on the word problems, it says there are 60 students presenting experiments at a science fair. The time allotted for all the presentations is 5 hours. How many minutes does each student have to present their experiments? So we have 5 hours for our 60 students. We want to figure out how many minutes each one has. So I need to turn hours into minutes. Since hours is in the numerator, it's going to go to the denominator. That means minutes are going to go on top. Hours can cancel out. I know that there are 60 minutes in 1 hour. So then go ahead and multiply across the top, and I'll get 300 minutes for 60 students. And then I want to know how many minutes per 1 student. So if I divide the top and the bottom by 60, I'll wind up with 5 minutes for one student. So each student is going to get 5 minutes to present. On number 2, there's quite a bit going on here. Just do your best. Come ask your teacher for help if you need it. But I do want you to try that on your own. And then the last 3 problems are review problems. Again, those are for you to do. Ask your teacher if you need help. All right, that's it for Unit 10, Section 1.